2x2 matrices and using those to solve systems. The first thing you need to know is how to find a determinant. Let me just remind you what we did back in Algebra 2. We would take the 7 times the negative 20. I usually just write my information right above the matrix. And then I take the 12 times the 8. And then we always subtract them. Alright? So the determinant is negative 140 minus 96. So it's like negative 240 plus 4. Negative 236. Yeah, I was right. That's pretty easy to solve. We use that in finding the inverse. So the next thing I want to show you is how to find an inverse. So the first thing we do, we need the determinant, right? 35 minus negative 100. So our determinant here is 135. Okay? Now, we switch the 5 and the 7. These elements are on what's called the main diagonal. In any square matrix, from the upper left to the lower right is called the main diagonal. So I switch those, physically pick them up and move them. The other two elements stay where they're at. They do not switch places, but I multiply them by negative 1. So that one gets multiplied by negative 1, and so does that one. The last thing I do is I multiply by the reciprocal of the determinant. Now, this whole thing is called the inverse. And for reasons which I will show you later, I don't necessarily think that you need to multiply the 1 over 135 into the matrix. I don't think you need 4 little fractions inside a matrix. I mean, we can, but I don't really think there's a point to it. Plus, when we get into solving, I'll show you what I do. Okay, solving a matrix equation. Let's just start with a basic matrix equation, AX equals B. And how do we solve that? First of all, you have to remember there is no matrix division. So don't try to, if I put a question like this, even with the letters like this, I do not want to see you divide by A. Alright? So we're solving for matrix X. We need to do something called left multiplication. If you were with me last year, we talked about this. You cannot, in matrix multiplication, it is not commutative. I talked about that in a different video. So I can't just switch things around however I feel like it. So if I multiply on the left side, I have to do that same thing to both sides of the equation. So for instance, we're going to multiply both sides of this matrix by A inverse. A inverse. Obviously, I'm talking about the inverse of the matrix A. Now, when we do that, these two things do something special. They become the identity matrix, right? Remember that whole thing, 1, 0, 0, 1? And the identity matrix times X is always equal to X. That's the equivalent of canceling out. Well, what happens on the other side is that I have A inverse on the left and B on the right. And those two things get multiplied together, and that will give me my final answer. You will also notice that it does not matter what size the matrices are, this property holds true. So these could be 10 by 10 matrices. Of course, anything 3 by 3 or larger we're going to use a graphing calculator for. But the 2 by 2s we're going to do by hand. Now, I've kind of run out of room, so I'm going to recopy down this next example because I don't have enough room where I wrote 2, 3, negative 3, 7 times matrix X equals big space 1141. Okay, so here is a matrix system. Yeah, probably. I need to get rid of this matrix. The only way I'm going to get rid of that matrix is to left multiply here and here by the inverse of that matrix. So the first thing I need is the determinant, right? 14 minus negative 9. That gives me 23, right? So I have 1 over 23 times. Switch the 2 and the 7. Multiply these by negative 1. And copy that down to the other side. Now, we all know, since we've done this correctly, that these three right here are going to turn into the identity matrix. Now, if I were you, I would hold on to this fraction and not worry about it. I would only deal with the integers, right? We have a 2 by 2 and a 2 by 1. So I know my answer is going to be a 2 by 1 column matrix. So I have, here, move over just a little bit. 7 times 11 is 77, plus negative 3 times 41, negative 123. And 77 minus 123 is negative 46. Row 2 times column 1. 3 times 11 is 33. 2 times 41 is 82. And 33 plus 82 is 115. Now, I ignored that fraction out in front until now. So I dealt with only integers when I did my matrix multiplication. But now, the identity matrix, right, the 1, 0, 0, 1, times matrix X just gives me X. And now I can take negative 46 and divide by 23. And 115 divided by 23. So I can find out that my answer matrix is for X is negative 2, 5. So that's the process of solving. You find the inverse and you left multiply on both sides. That's why I left the big space over here between my equal sign and my answer matrix on the other side. My constant matrix. Okay, well, we can do the same type of thing with a problem like this. Solve using matrices. Well, we start off with a system of two linear equations, and we want to change it to a matrix system. You'll notice that I picked the coefficients 1, 3, negative 6, 5, and I put them in a coefficient matrix. We have the variable matrix, which is a column matrix. And then we have the constant matrix, which is the constants that it's equal to on the end. Alright, so we need to find, let's see here, 5 minus, right, 5 minus negative 18 is 23. How interesting. So 1 over 23, switch the 1 and the 5, multiply the other ones by negative 1, and copy that down to the other side. We know this is going to turn into the identity matrix, which is just xy. And over here we have 1 over 23 times 2 by 2, 2 by 1. Yes, that's going to be a 2 by 1 answer. And let me see if I can do this here. 5 times negative 24, that's negative 120, plus negative 3 times 29, negative 80, no, negative 87. So that gives me negative 207. Lastly, I have this row times this column. That would be negative 24 times 6 is negative 144 plus 29, and that gives me negative 115. Negative 207 divided by 23 gives me negative 9, and negative 115 divided by 23, that'd probably be negative 5. So there's your answer for that particular question, using left multiplication by the inverse of the coefficient matrix. Talk to you in class.